Okay, folks, so today, log entry, 202112261349, and we're gonna be working on the SparkFun Inventors kit, and we're gonna be doing circuit number 3C, motion alarm. Now you can see our little R diagram we know. Yes, that's right, that's the R diagram we know. R diagram we know. Yeah, that's it. R diagram Arduino. Right. Anyways, we're gonna keep the same configuration as we had from circuit number 3B, and we're going to be adding piezoelectric device. No, I'm still not used to this camera here. I don't know how, like, it doesn't have auto zoom. It cost me about $50. It's Creative Labs, whatever. So we're gonna be throwing that guy on, and we're gonna be including this along with the already wired up ultrasonic sensor and RGB LED. So this one, for example, if you know what, never mind, I'm not even gonna power it up. I'm just gonna start jacking this stuff in here. Okay, so this one goes, the piezoelectric goes F14 to F16. Oh, except which one's the positive? Okay, so F14 is the positive. Boom. There we go. And now we will add this black one from J16 to the ground negative. There we go. And we will add this guy from J14 to D10, I think. Is that it? Yeah, 14 to digital 10. So the piezo is connected to digital 10. The ultrasonic sensors are connected to digitals 11 and 12. And okay, what do we have left here is the servo. Okay, so our servo's gonna go to digital 9. Digital 9 for the instruction sets. And then the other two wires will be for the electricity. Oh man, yeah, that's sweet. Yeah, and like even the white one on here, the little box, it says like next to the white one, it's got some bunch of extra like writing on there, so that's helpful. Okay, so where does the black one go? The black one goes to the negative ground, like this, the negative electricity thingy. And then this one goes to the positive, to the red. And it will go to, yeah, okay. And this one will go to the positive up here. Yes. Okay, so we are all jacked up, folks. So let's get this guy wired. So here's what's gonna happen. Okay, so right now we've got the old program, and you can see that the light is orange, or yeah, it's orange, right? Because the monitor the computer monitor that it's pointing at is roughly 18 inches away. If I pull back, it should turn to red or green back beyond about 20 inches. Okay, so that's green. Okay, so at green, okay. So, see, further back, it's green. If I move up, it's yellow. And if I get too close, it goes red. So I don't know if you guys can see. I can see it go red. Yeah, see, there it is. Oh. See? You can see it's red. And then it goes to yellow. And then it goes to green. So that was based on the past programming, and it did not account for the servo, and it did not account for the piezo. So let's just open up our Arduino. Yup, we're going to open our Arduino IDE platform right now. Now, this servo actually has a little Velcro strip right here. This is not actual Velcro. I don't know what the name of it is. It contains like these little trichome-like structures, and it's awesome. It's amazing. Stuff works like genius. I can only imagine how someone discovered that. Anyways, now that we've got our Arduino ready, let's find the correct exercise. Okay, so they always open up in this other side window, and I don't like that very much. So I go like this, and then like this. Ah, come on. Okay, yeah. Ah, come on, man. Okay, like this. Okay. Yes. Yes. No. No. Yes. Okay, so what do we have? So we're calling the servo library, the trigger and the echo. Okay, so these are our sonar. These are digital 11, 12 for our sonar. This is digital 3, 5, and 6 for my, so that's, okay, so these two are digitals 11 and 12 up here for my sonar, and then these ones are digitals 3, 5, and 6 for my RGB. I must be shorting it out when I'm doing this. Like I must be blocking one of the pieces. Yeah. That's it. Whatever. Anyways, and then we've got pin 10 for right here for our buzzer. Yep, There it is. And yeah, pin 9 for the servo. Yeah, there it is. Wait a minute, how does this work again for SIK 3? Yes, okay, so that does make sense. Yeah, sorry, I got confused. I thought this, yeah, so this is the sonar, and then the servo is down here. So we're creating the object of the server, but it's not, we haven't identified it as being a global variable. The buzzer's in 10, okay, so this is a variable to store the distance sensed by the ultrasonic. So this tells us to load up with the computer. Right here we're sensing the ultrasonic distance. Here we're determining, and there should be functions for all of these things down here. So for example, oh no, my mistake. Okay, so those are normal, they're just natural. Yeah, okay, so you're basically just telling it, so for all of your digitals, do you want it to be an input or do you want it to be an output? And then here we're attaching the object that we created to digital 9 rather than having kind of like called it as a global variable. Okay, so now we're running our program, which consists of identifying the distance. And get distance is a function that it is created down here, and it basically says ping, use your sonar to make a ping, divide whatever by a constant, which appears to be something like 10, and then determine that to sort of like use that to determine what that equals in time. And it's based out of 148 units. I think that's inches. I think that 148 divided by 39.25. Yeah, so that's roughly probably the amount of inches of sensory range. Okay, so anyways, so we determine the distance, and then so we print the distance to the console for people to see. And so as you can see, we're about 2 inches off of the keyboard there. My sensor is man, for whatever reason this Arduino really kills my RAM. See, but you can see the sensor right here. It's about 2 inches from the keyboard. Okay, so what else? Holy jeez. Yeah, like my CPU's at 100%. But it's from OBS. It's from recording. Anyways, whatever. What else are we looking at here? Oh, it's okay, so it's from having 2 different recordings, because I'm recording with this camera, this one, but I'm also screen grabbing with OBS. See? So that's why my CPU's running at 100% and my GPU is only running at 50. So that's not efficient, but whatever. Okay, so anyways, ultimately these lines here will produce this effect down here. Meanwhile, if it happens that the distance falls into this way, we'll keep our color coding. I guess this is probably the same code as we already had. However, we're adding the buzzer and we're adding the servo commands. Okay, so we're basically telling the servo to rotate by these degrees, and we're telling the buzzer to make a sound on and off, and we're telling it to be delayed by this to be on a frequency of 10 times per second, if I'm interpreting that correctly. So what else? Yeah, so, and that this behavior will change based on the difference away from the object, but only the light bulb will change, not the frequency of the rotations. Now, our project book here actually tells to create this fake cat, and like you can see, oh man, come on. See, like you can see this blurry thing here is supposed to be this magazine cutout of this cat. And like, I'm just not gonna do that. I don't care. I don't care about that stuff. So what I'm gonna do is I'm gonna load the program, and we're just gonna keep our eye on this servo, and we're gonna listen for the buzzer, and we're gonna watch the lights. So in the meantime, just keep an eye on these lights right here, because one, you should see a yellow one as the code gets loaded. So watch out for that yellow light right here. We must have already seen it tonight. Oh no, it's still loading. We're still loading. Yeah, you can see the green bar down here, see? Okay, so get ready to watch out for the yellow light right here. Oh, there it is. Okay. So we're live with the program. And yeah, so oh, you know what? I was mistaken in my interpretation. So it turns out that the servo is only good in 10 inches and lower. The servo is not programmed to be here. But let's alter up this code a little bit. Let's go like this, and like let's go like this and like this. And then we'll go like this and like this. And like this and like this, and then we'll go like this. And then on this one, we'll go like 165. Ah, come on. And then like this. So we should get even more vigorous action. Okay, actually, let's just reverse this up, and let's put this one right here, and then this one down here. Yes, so we should get vigor as we approach the target. As we move away from the target, we should get lethargy or torpidity in the, what's it called? Servo. The lighting will remain the same. Oh, I forgot that I was unplugged. Oh, friggity. Okay. Okay, so let's go like this. Again, watch out for that yellow light. Oh, there it is. Saw the yellow light that was there. Okay, so okay, so stupid me. I only changed the comments, not the actual code, so we'll just quickly update this. And man, that was so embarrassing and stuff, but hey, it's part of the learning process. Oh man, jeez. Okay, so let's get this show on the road. Okay, so what I've discovered is that rather than update the frequency of the rotations, it changes just the positioning of the rotations, which, you know, was obviously very clear. It's just my lack of experience with these instruments has not yet allowed for me to form intuitive outcome thinking. Anyways, that's it for this video, folks. I hope you enjoyed it. Again, that's the SparkFun Inventor's kit, and we're looking at this guy here for circuit 3C motion alarm.